All right, welcome to the Explainer. Today we're going to get right into it and go deep, I mean really deep, inside your muscles to figure out what is actually happening when you hit that wall during a workout.
You know the feeling, we've all been there. You're pushing through that final, absolutely brutal set. Every single muscle fiber is just screaming at you. The weight feels like it's doubled, and your strength, it just feels like it's vanishing into thin air. And then, that's it. You hit the wall. You have to stop.
It's a feeling we all know intimately, right? But what is physically going on, down at the microscopic level that forces our muscles to just stop working? Is it that you run out of fuel? Is it that famous lactic acid burn we always hear about? Well, for a long, long time, the exact point of mechanical failure has been a bit of a scientific mystery.
So, to really get to the bottom of this, we're looking at a fascinating study from the Journal of Physiology that isolated the exact point where things break down. But first, to really get what they found, we need to be super clear about what hitting the wall actually means in the lab.
See, to a scientist, fatigue isn't just about feeling tired or sore. Nope, it's a measurable physical thing. It's a specific moment your muscles physically cannot produce the same amount of force they could when you started. It's a performance drop-off, and that's what we're digging into today.
Okay, so let's get into the good stuff. To understand why the engine stalls out, we've got to look at the engine itself. So we're zooming way in, past the gym, past your skin, deep inside a single muscle fiber, to meet the tiny molecular motors that make every single movement possible.
The easiest way to picture this is to imagine that each muscle fiber is packed with millions, and I mean millions, of tiny rowers. In reality, they're protein interactions called cross bridges, but just think of them as a massive crew, each one grabbing an oar, pulling with all its might, and then letting go, over and over and over again. This giant, coordinated effort is what generates all your strength.
So it really all boils down to your crew. Your total strength at any given moment is a combination of just two things: how many of your rowers are actually rowing, and how hard each one of them is pulling. This means for you to get weaker, one of two things must be happening. Either you have fewer rowers in the water, or the ones you do have are getting way weaker at pulling. It's got to be one or the other, or maybe both.
And this is where the research gets really interesting. The scientists put these tiny rowers to the test. They basically made isolated muscle fibers contract over and over again to cause fatigue, all while measuring force and cleverly tracking the number of active rowers.
Now, the logical assumption, and what a lot of people thought for a long time, is that as you get tired, your rowers just start to quit, right? They drop their oars one by one, the total number of active rowers goes down, and that's why you lose strength. But the data showed something completely different and way more surprising.
Okay, now what's so wild about this slide is the disconnect it shows. Take a look at the black dots. That's your force output. You can see it just plummets, dropping nearly 20% in just the first 15 or 20 contractions. But now look at the white dots. That represents the number of active rowers, and it barely moves.
This was the first huge clue. It's a real head-scratcher. The entire crew is still at their stations, they are all still participating, but the force they're generating as a team is just dropping off a cliff. So that tells us something isn't happening to the number of rowers, something is happening to the rowers themselves. And this graph right here is the aha moment. The researchers dug even deeper to figure out the force being produced by each individual rower. Here, the circles are total force, the triangles are the number of rowers, but the squares are the key. That's the force per rower.
This data completely changes how we think about fatigue. It's not one thing, it's a two-stage attack. In phase 1, that first big drop in strength you feel, it's because every single rower has gotten weaker. They're still trying, but their pulls are feeble. Then, and only when fatigue gets really bad, does phase 2 kick in. That's when the rowers finally start to give up and quit altogether.
So this is a massive step forward, right? We know that first, the individual rowers get weak, and then they start to quit. But that just leads us to the next massive question. Why? Why do they get weaker in the first place? What is sabotaging their strength?
Well, the answer isn't a lack of energy, and it's not lactic acid. The prime suspect, based on this study and a ton of other research, is a chemical byproduct called inorganic phosphate, or just PI for short. Every time your muscles contract, you break down your main energy molecule, ATP, and PI is one of the things left over.
So here's how it all goes down. As you're banging out those intense reps, this pi stuff builds up fast inside your muscle cells. Think of it like chemical sludge flooding the engine room. This sludge, this high concentration of pi, directly gets in the way of the rower's ability to pull on its oar. It literally gums up the works, pushing those cross bridges into a low-force state, where they're still attached, but they just can't pull hard anymore. And that is the direct cause of that first phase of fatigue.
Now, this isn't just some cool, nerdy science. Understanding this two-phase attack and the role that pi plays can completely change how you think about your training, your endurance, and how you push past what you thought were your limits.
And here's the most exciting part, and this comes straight from the study's authors. They suggest that if the first domino to fall is this rapid rise in pi, then the solution is to find ways to limit it. This could mean changing how you train or even developing supplements, what they literally call phosphate mops, that could help clear that sludge out faster.
So the real takeaway here is that hitting the wall isn't a failure of your willpower. It's a failure of your internal chemistry. And knowing that is incredibly empowering. It lets you think strategically. How can you set up your rest periods to let that pi clear out? Are there nutritional strategies or supplements like creatine that might help manage this chemical environment and let your crew of rowers pull harder for longer?
So the next time you feel that burn and your strength starts to fade, you'll know exactly what's going on inside. It's not your rowers quitting on you. Not at first, anyway. It's your entire army of rowers getting weaker, fighting against a rising tide of phosphate. Your job now is to figure out how to manage that tide. Thanks so much for joining this explainer. We hope this gives you a brand new edge in your next workout.